Hi, everyone. My name is Regis James, and today I'm going to be discussing with you leveraging AI literacy, governance, and data quality principles to minimize risk. So I'm presently an associate director of data science at Regeneron Pharmaceuticals, and I have a PhD in structural and computational biology and molecular biophysics. And I use some of those skills that I developed in that degree to build some AI tools that I'll be discussing today. Um, I'm also the head of a data science and AI community of practice. We are at about 460 people company-wide as of today. And it's been around since, well, basically the entire 9 years I've been at the company. And I'm also a thought partner in AI recommendation engine architect and have been so since around 2008. So there are three overall chunks to this talk. First, we'll be talking about aligning on what AI is, and then we'll be discussing the need for AI-specific governance, and then governance within Magnetron AI, which is one of Regeneron's internal patent-pending AI tools that I worked with collaborators to build from scratch. So let's talk about ChatGPT. It's what people right now in Q4 of 2024 often think about when they hear about AI. So let's just get it out of the way. So what is it? Well, it's an AI chatbot. It's also a great use of large language model technology. So just to help contextualize everything mechanistically speaking, the autocomplete on your phone is basically a small language model because it's making recommendations of what words to put next in your stream of text in your sentences based on all the words that it knows that you've said before. And so a large language model is doing the same thing, but using all of the internet or a massive chunk of the internet. And because of this, it's a game changer. So how exactly does it work? Well, it uses what's called deep learning to recognize patterns in how humans have communicated online, and then it acts on those patterns to help you get done with a lot more things a lot more quickly. And so some of those things could include, as you already know, content generation, personal productivity, tutoring, creative writing, and the list goes on and on. But here's the thing, ChatGPT isn't the only AI out there. And so if we take a step back and think about what exactly we mean by AI, we can ask ourselves a question. Seems silly, but actually there's a point here. So what is a sandwich? We all think we know what a sandwich is, but opinions have varied. So most people will agree that this is a sandwich, and also this sub is a sandwich. But then let's start drifting into a kind of a weird direction. Is a hot dog a sandwich? It has some of the standard components, fits within the definition. What about a hamburger? Yes, we might agree that that's a sandwich, but now I'm about to get edgy. Is that a sandwich? It's called an open-faced sandwich, but if you just make it a little bit bigger and switch out some of the toppings, now you have a pizza. Is that a sandwich? An ice cream sandwich literally has sandwich in the name, and so does an Oreo, a sandwich cookie. So perspectives have also varied about AI and its evolution. So the truth is AI did not appear overnight. Similar to the way that smartphones have been around for a while, but they're just the latest iteration of something that was built a long time ago. 1876, Alexander Graham Bell, the telephone, and then similarly in terms of chatbots, the ELIZA chatbot was invented in 1967, which is older than most of the people in this room. So fun fact, you've already been relying on AI in your everyday life for years. So virtual assistants, we all know that's AI, right? But forecasting, so that's models of the future of meteorology. Media recommendations like Netflix or Spotify, generative AI, of course, we know that one. Matchmaking, Match.com, Bumble, eHarmony, Magnetron AI, which I'm going to be talking about a bit later, search engines, anomaly detection, image and visual recognition. And so with many of these AI technologies, a pattern often emerges. So what usually starts is there's a technological trigger, and then everyone and their mother gets excited all over the planet, and they're like, oh, wow, it can do every single thing. And then they realize, actually, it can't can't do the kitchen sink. So then they hit the trough of disillusionment. And then once they slowly start to accept things, so it's also like the stages of grief, I guess, there's the slope of enlightenment, right? And then you hit that plateau of productivity where you realize, oh, it can't do everything, but it can do some things, and it can do some things kind of well, as long as it's not hallucinating. So we're at different points along this maturity curve, depending on the application and depending on who you ask. So then what exactly is AI? Well, first, let's talk about what human intelligence is. And I know it's not necessarily the ideal yardstick against which to measure what AI is, but it's one that we're all familiar with because we are running human intelligence engines in our own skulls. So intelligence is the ability to learn from experience and to adapt to, shape, and select environments. So then what's the artificial version of that? Well, basically, the AI version is the ability to think. It's a machine-based system that's designed to operate within varying levels of autonomy and that can adapt after deployment. So after you've made the thing and you send it out, it can do different things from what you programmed it to do in with maybe finer grained ranges of variability. Machine learning is the process of optimizing model parameters through computational techniques. So automatically learning what to do by looking at data. But this means that AI has evolved beyond mere data processing to include the development of machines that are capable of learning, reasoning, and problem solving. But it also means that there are levels to what's possible with AI. So first we have maybe descriptive, right? So an explanation of what's happened. You can think of that as kind of a report, right? So that's mostly not thinking as much, but just saying this is what happens. But then once you start sprinkling in a bit more of the thinking, well, you get to diagnostic. Why did what happened? And then the next step beyond that is predictive. Well, given that's why that happened, this is probably what could happen because of what we know about what is happening. I know I said happening a lot. And then the next step is, well, because we think this is what's going to happen, this is what you should do. This is what you should make happen. So prescriptive or recommendations. And then the next one is, since I think this is what should happen, I'm going to go ahead and make it happen. So that's cognitive. And so AI assistants can help optimize a wide range of human efforts. And so if you think about it in terms of what that means that these AI platforms can become a central source of, we start at the simplest case, which is a central source of truth. That's a descriptive. But then we have a central source of thinking, of logic. And then on top of all of that, we have a central source of action, which can really help scale, which again, I'm going to touch on a bit later. So then how exactly do we build new AI tools? Data science, of course. So data science, one way to think of it or think about implementing it is starting at the end and working backwards. So one definition of data science is the use of computational approaches, and by that I mean automation, AI, ML, etc., to enable specific decisions towards desired outcomes. And so when I say outcomes, what I mean is some sort of improvement in a context or area, which is only possible because an action has been taken, which is a resource expenditure. And that action was only taken because a decision was made to do so. And so a decision can only happen because you've reached sufficient confidence, because you've reduced the ambiguity about whatever situation that you're thinking through. And that only happens because you have answers about the situation. So you have received data that is explaining the causality of the situation that is at hand. And that only happens because you've asked a question. So you've attempted to remove gaps in your understanding of the situation. So if we think about all of this in terms of what data science and AI machine learning are, well, data science is using data to figure out which decisions to make, and artificial intelligence is simulating autonomous human thinking, reasoning, and behavior. And you use software engineering to do that. So there's a place where artificial intelligence and data science overlap that does not include machine learning, and that's directly telling the computer the decision-making rules, those patterns. But then machine learning is making the computer figure out the decision-making rules. And then a subset of that is deep learning, which is making the computer use multiple layers of thought to figure out those decision-making rules. And then the innermost part there, at least for the purposes of this talk, is large language model technology, which is achieved by making the computer figure out the decision-making rules for best understanding and generating human language. And so this is what ChatGPT does. So if we think about this data science framework, we basically start at the end by defining what that problem is, what that desired outcome is, and then everything else that we do is identify and eliminate obstacles. So basically decision or data science is decision science. And data-driven decision-making, as I alluded to earlier, is just minimizing ambiguity. And so I'll walk you through kind of like a schematic of what I mean by this. So if you have a road, right, that splits, there's a fork in the road, there's two options that you can take, right? And you intend to take the option that is best for you, whatever that may mean, right? But if you don't know anything about either of the roads, you have a lot of ambiguity and not that much clarity. And so that yields a low level of confidence. And the justification that you have for picking one road or another is too low. And this has to do with that decision-making threshold, which is a function of how much the situation matters. So if something really matters, that threshold for making a decision is very high. You need a lot of information. But if it doesn't matter that much, you can, call it without knowing that much about the situation. But that decision-making threshold is always there for every decision that we make. But if you find out that there's some sort of harm or hazard down the road of one of the forked roads, then it kind of reduces that ambiguity about what decision you should make. And so this is where our brains naturally develop confidence about potential outcome chances when we have this reduced ambiguity and increased clarity. And so that results in enough confidence that bumps you over that decision-making threshold, and you have at least enough knowledge to decide to not go down the potentially harmful road and instead to review the road that's less harmful. So that takes us from a position of stuck to unstuck, which is the goal of data science, so that we don't have these obstacles, right? And so AI is ideal for enabling and accelerating decisions like this when the data is either big or complex, or both big and complex. And in the industry that I'm in, so pharmaceutical industry, the data is definitely both big and complex. And if we think about a lot of the different sectors along the pipeline in pharma, so we've got research and discovery, clinical development, manufacturing and supply chain, launch and commercial, and post-market surveillance patient support, AI can help accelerate decisions at every step of the way. So just a brief recap for this first section of the talk. So what is AI? It's computer technology that can think for itself. It can recommend or implement decisions on its own. And ideally, and this is what I'm about to touch on, it's safe and controllable by humans. So why might you need it? Well, to help accelerate or unblock complex decisions that you're responsible for, and to become more accurate, precise, and consistent. That central source of truth, central source of logic, and central source of action. But are there possible challenges to this? Yes. And that depends on how good the AI is at thinking through decisions. So then if we think about what we mean by what makes an AI good enough, I've thrown up a couple movies that all touch on the safety or concerns about AI and how it can think. So there are thresholds and expectations that we can use for evaluating whether or not an AI is good enough. There are many different ways, but two of them here are thinking about the Turing test and human safety. So the Turing test is passed by an AI system when the decisions made by that AI are indistinguishable from those made by a real human. So one might argue that the modern implementation of the latest version of ChatGPT does pass the Turing test, because you might not always be able to tell if it's a human you're talking to or not, if it weren't for the interface that says this is ChatGPT around it. And now in terms of the human safety, oversight over decisions that are recommended or executed by the AI, that's absolutely required that humans be in charge of that as well. So then the key is that AI makes decisions that are autonomous, so on its own, they're intentional, so it knows what it's doing and it's doing it on purpose. They're reasonable, so it's logical, and they're also adaptable. So depending on the situation, it can behave differently. And then also safe, and most important, so last but definitely not least, it has to be harmless to humans. So if we take another step back and think about then how we make decisions on what is the right thing and what's not the right thing. We actually mentally model the universe. So if you think about it in terms of like, if you see someone flip a switch and then a light comes on, you think, okay, well, there's causality. I need to read this piece of paper that has a bunch of text on it. I can't read it right now. So it would be really good if there were more illumination so that now I can read the words. And it's bad right now because there's not enough illumination, so I can't read the text. So therefore, the good decision I should do is flip the switch. So we make the decision saying this is probably right to flip the switch and it's probably wrong to not flip the switch. And so AI processes this kind of thing too because it creates models of the universe and the mechanisms that exist within it. And so because either if you're using machine learning or if you're manually putting in the rules for its behavior, the better the data that is the basis of this model, the better the model and its corresponding decision recommendations. But how the AI is distinguishing between right and wrong is extremely important. And if an AI is making recommendations or decisions autonomously, then human oversight is mandatory. And this is what we mean by AI governance. And throughout the rest of this talk, I'm going to be indicating where AI governance is at play by this green gavel here. So what exactly is AI governance? Well, it's the frameworks, policies, and processes that are specifically designed to ensure ethical, accountable, and transparent development and deployment of AI systems. So the purposes of it are in terms of quality, transparency and stakeholder engagement, ethical development and fairness, accountability and compliance, and also risk management and security. So with this information, I'm going to move into the third chunk of the talk and discuss Magnetron AI, how I built it, and how I incorporated these different types of principles and purposes into building a 10x mentor matching AI platform that was safe and accurate and effective. So just to contextualize here what Magnetron was, there are three chunks that I'm going to go through here, or sub-chunks. So first I'm going to talk about what the worthwhile challenge that we had at Regeneron was, and then how the scalable solution was built, and then tie in that flexible framework that I was talking about earlier for impactful data science. So at Regeneron and all the companies and other types of institutions that you work at, we all can stay ahead of the game by upholding an ongoing responsibility to help improve the lives of others. And we can do this by continuously focusing on evolving our people, our process, and our technology. And so some of the ways that we can some of the ways that we can invest in our people or our employees are providing growth opportunities, including things like mentorship, support of internal groups that facilitate networking, creating diversity opportunities, and enabling work-life balance. So at Regeneron, we had a challenge that was pretty difficult, but it was worth it. So our mentoring cohorts had grown substantially every single year, right? So in 2022, we had 126 applicants. And then 2023, last year, we had 345 applicants. And then this year, we had about 500 applicants in one of the many cohorts that we do. But if you multiply the number of mentor applicants by mentee applicants, each year, that number got extremely ridiculous. So it went from 3,864 choices to, what is that, 20 times the number of possible choices this year. So if you scale the amount of time that it took to do manually in 2022, which was about half a month, well, that number gets pretty insane. So this year it would have taken 10.8 months, so about 11 months, way too long. So manual matchmaking across all of the submitted applications was impossible. And then just randomly pairing people together, just saying, oh, this is an application, that's an application, let's stick them together. Hopefully the mentor can help the mentee be better at the responsibilities that the company is paying them to do. If you just randomly stick people together, that'll disappoint everyone and make everyone frustrated. So the challenge was that we had too few resources, even with the growth that Regeneron was experiencing. The quantity of possible choices was far greater than the amount of resource that we had. So if done manually, it's irritating, or it would take too long to do right, and embarrassing or unsatisfying to participants if you do it quickly or randomly. So we needed a way to easily consider more people's requests. Marvel alert, by the way. So, and scalably, so where 20% or 20 times the possibilities did not equal 20x of the time. So how could we quickly review the 84,000 possibilities and find everyone's best match in far less than a year? So what did we do? We implemented first an improvement on data quality. So I hadn't talked about this much, but if you want to make a scalable AI solution, you can't start with your shoelaces tied together. So what we did was we took the unstructured, disparate data and we made it structured and consolidated. We took data from Microsoft Forms, Microsoft Excel, Microsoft Teams, Active Directory, Workday, and we put it all into structured data. So MySQL relational database and Neo4j graph database. Of course, governance was also applied here too, because excuse me, not everyone should be allowed to access all of the data. So depending on the role of the person who is involved in this collaboration, we restricted access, and then, but we did allow access and even connected additional dots where appropriate. And then we built that scalable solution that I've been alluding to. And basically, it was just an AI version of the pre-existing manual process with a whole bunch of extra supercharging bells and whistles. So that meant that the AI augmentation of the resource flipped the equation. And so now the resource that we had far outweighed the number of testable options. So what we did was built Magnetron. So Magnetron is an acronym, and it stands for Mentoring and Growing Next Generation Talent at Regeneron Online. There's a whole history behind it. It's patent pending. Also, by the way, if you Google Magnetron, it's also that thing that heats up your food in the microwave. I didn't know this. But because of the AI that's in my pocket, I do think there's a chance that like Google and YouTube tend to listen to things that are being said. One day there was a recommendation on my phone about, hey, would you like to know how a microwave worked? And I thought, I don't have anything better to do. I clicked it, Magnetron, that's what it is. But what we did with Magnetron was we were able to, and look at just how beautiful that drop is, right? So we had the curve that would have been 11 months. It only took 1 month because of the use of Magnetron. And so what it did was enabled for cohort sizes to increase without substantially increasing the matching time. So I'm going to try to fold everything in from what I've been talking about thus far. So if you recall from our data science framework solution that we were discussing, where we start by defining the outcome that we want and then work backwards to identify and eliminate those obstacles, we did the same thing here with Magnetron. But in order to talk about the things that I use to do that, I first need to talk about some previously effective implementations of this framework in other AI tools that I then leveraged for Magnetron. So during my PhD, for example, one of the things I built was this tool called OMIM Explorer, and I'm not going to go into details about how it works, but the slides are on the app for the conference and the URL at the bottom, youtube.com/@data-driven decision-making. So @data-driven decision-making, you can see the talk that I gave about that and how that worked. But basically, the desired outcome was that genetic disease patients are given the most accurate diagnoses and treatments. So patients, you sequence their genome, you say, oh, this is a weird thing in your genome, that's a weird thing in your genome. You look at the symptoms. All right, this shouldn't be happening to your body, that shouldn't be happening to your body. Mix it all together, get a relevant diagnosis. So basically the decision, and I'm using the same graphic from earlier, there's a fork in the road, which road makes the most sense? So it's between diagnosis A and diagnosis B. And again, I won't go into the details here, but you can see it on YouTube. But some of the approaches and technologies that I used for removing these obstacles to an accurate diagnosis were ontologies, which are hierarchical vocabularies, and then embedding like annotations. So what I mean by embedding is a vectorial representation, so representing an object in terms of a series of numbers, and then annotations, so associating, saying this set of numbers is about you, that set of numbers is about you. So these are links between entities, so entities can be a person or a disease, and they're vectorial representations of the ontologies as numbers. And then semantic similarity. We all do semantic similarity all the time. An apple is like an orange because it's like a fruit. Even though people say it's like comparing apples and oranges, that's not a thing. It is. You can compare it, right? They're fruits. They're edible. They're not poisonous most of the time. Snow White. Anyway, but yeah, so semantic similarity, matching using ontological annotations, and then transitive prioritization. So this is Kevin Bacon stuff, right? Like guilt by association, and then saying, well, who's the closest to Kevin Bacon? Well, let's put that one up at the top. So transitive prioritization, rank by your intermediate associations that propagate. So that was during my PhD. Keep those in mind, right? And then so another one that I've done at Regeneron is a different desired outcome. So we want to target disease genes with the potentially most effective modality that we have at Regeneron for hitting genes so that we can treat disease. So I can represent everything, and I did, inside of this. It looks like a spider web, and it actually is represented this way in the database. But basically, the question is, which gene should we target? Because you can have gene-gene interactions, right? So the question, that fork in the road, is gene A or gene B, with the different hammer or the nail, the different types of tools that we have at Regeneron. So some of the approaches, again, I won't go into this, it's on YouTube, but some of the approaches that we use were knowledge graphs. So these interconnected spider webs of data. The Neo4j graph database, so that's a knowledge graph server. It holds that spider web. Cipher, which is the language used for querying that knowledge graph database. Okay, so then how did we apply all of these types of approaches to scale mentor matching? So in other words, how do we reduce this information via AI and evaluate all of the different possibilities? Well, the real question here, and this is really important if you're building any sort of AI solution, and then, of course, as you're building the solution, you need to keep in mind the governance. So the answer to which things should we govern is only possible if you can get the answer to what are we actually trying to do first. So the real question is, what outcome did Magnetron AI need to prioritize decision recommendations towards? Okay, well then here's that outcome. Employees that are in need of specific skills for doing their jobs and for advancing in their careers, they're matched with others who are best suited to help them develop those skills. So then that means the recommendation was the decision to match each mentee with the mentor that could best provide help. So that fork in the road decision is mentor A or mentor B. So if we take that framework from earlier, right, there's the desired end of the outcome and the action, and then the answer is minimum necessary data identified by working backwards from that desired outcome. And of course, the very first step is that question. What's the approach that's necessary for collecting that requisite data? Magnetron addresses all of these things. And it also builds that engine in the middle, because that's the most important part, converting the data into a recommendation, that central source of logic that I was alluding to earlier. So how exactly does Magnetron work? Again, I'm not going to go into all the details because there's a lot in the patent. It's like 86 pages now in our submission. But just suffice it to understand that we use R and Python in what we're doing. And at the highest level, there's two steps: filter to what's relevant and eligible, and then sort by the best match, Kevin Bacon style, right? So the filtering part reuses some of those earlier AI approaches that I mentioned before. So knowledge graphs, Neo4j graph database for holding the knowledge graph, cipher query language for querying that graph database, hierarchies. And then the sort step uses annotation embedding, semantic similarity, transitive prioritization. And of course, governance is applied here too, because the AI is making decisions about what to recommend and what not to recommend. So at every step of the way, I built in place the ability for humans to govern how the AI is working, and I will get into that. But also, I democratized everything. So I used R, I used Python, and one approach to doing this is using, first building a knowledge base of all the definitions of the cohorts, applicant attributes, governance configurations, and language. I use large language models, Neo4j, MySQL, an API for programmatic association mining, these connections that dig into that knowledge base, and that is the recommendation engine that I was talking about earlier. And then building a user-friendly interface. I use Shiny for this, for working with the engine and explaining the reasoning behind recommendations. That's another really important part, right? You can have humans in control of how it works, but if it's black box to them, it doesn't matter that they have control if they don't understand what they're controlling. So the explainability is absolutely crucial. And of course, all of this is optimized in a way that allows the AI to do a bunch of things all at the same time and in the background. So using things called asynchrony and parallelization. And then I orchestrated all of this together with this design pattern. So the model view controller. So let's say there's someone named Kai, right? One of the people at our company. And of course, hopefully this is, I'm abstracting enough that you could apply to your different use cases at your own institutions. But let's say Kai opens up the view, right? And then Kai asks a question. The view automatically in the background makes a programmatic request through the API, which then hits the model that has all these technologies I talked about. Then that returns an answer through the API and then shows it nicely in the view, which makes it easier to separate and organize the application into distinct manageable components. It makes it easier to add and debug functionality to one component without having to dig through and modify the entire code base. And it also makes it better for collaborative and tandem programming because it minimizes the likelihood of code clashes. Again, we're trying to minimize risk, maximize impact. So at every single step of the way, in terms of this entire AI architecture, this is what I've kept in the forefront of my mind. And it also, as a result, makes future-proofing really easy. As of course you can imagine, there's governance applied at every step of the way too. Who's allowed to access the view? Who's allowed to access which cohort? Who's allowed to access which application that has been submitted? Who's allowed to make a request to the API? Who's allowed to ask a question of the database on the back end? All of this is implemented using the FAIR principles, which is an acronym for findable, accessible, interoperable, and reusable. Very important here, and it's the governance that I was just talking about. So wrapping everything up, these are what the AI, the Magnetron AI's current user stories are. So a designer can go in and create the cohort. They have full control over adjusting the configuration of that cohort. And then once they create the cohort, the timeline begins because they decide when the application window or period begins and when it ends. And within that period, people can apply to be a mentor or mentee. So they can submit their applications, and then they, because of the governance controls that are present, they can go in and edit their answers at any point throughout the application period. And so Magnetron automatically sends a notification to the approver and says, hey, there have been applications that have been received, and the approver at Regeneron at least is someone in HR. They may have additional records. Everyone at Regeneron is great, so there's really no role for them. So the approver may say, hey, you are or are not allowed to participate for whatever reason. Never happens. And so once they apply their governance role there, the nominator, another admin role, can go in, evaluate all of the eligible pairs that are generated by Magnetron that takes into account all of the requirements for what's allowed to be a match or what's not allowed to be a match that were defined by the designer. And then what's allowed to be a pair and not allowed to be a pair that are defined by the different applicants. So to kind of clarify how that works, if you think about it in terms of 10 people who identify as a man and 10 people who identify as a woman, that does not mean you're going to have 10 pairs. That might mean you have 1 or 2 pairs at best if you just pick 20 random people, right? So similarly here in the applications, all of these governance controls over what the AI is allowed to associate and what's not, they're all taken into consideration with this nomination step. And as the nomination is being done, by the way, so that asynchrony and parallelization that I was talking about before is used here. Because every time a nomination is made, Magnetron in the background hits a large language model and takes all of the preference information from those 10 men identifying and 10 women identifying people, but in corporate context, of course. So it takes all that information into account and then generates recommendations of what the people who end up being matched should discuss. But it also keeps private information. So if the mentor says, okay, in my additional information, this is important to me, please keep this a secret, and the mentee says something similar, that information is not mixed together. That governance keeps those parts apart. So that is also annotated by the reviewer as well. the reviewer may have additional information to give recommendations to the nominator to say, whoa, actually you shouldn't do this because X, Y, Z reasons. And so then a notification is sent to the approver, who may be able to reject the nominations for one reason or another. And this is all downstream of decisions and recommendations that the AI has made. So these are humans at the center of everything that the AI does. If an approver rejects a nomination, then Magnetron says, okay, I won't use that one then. And then it tells the nominator, hey, you got to replace this nomination, which they do, and then that repeats that cycle. But if an approver approves, then Magnetron automatically sends a notification to the mentee applicant. So the mentee, who typically has less advantage than the mentor, has the ability to make the decision on how pairs should proceed. And so if they reject it, does the same thing as with the approver rejection. But if they accept, then Magnetron sends a notification to the mentor. So these are all of the different things that are happening. And so you can see, obviously, it takes teamwork, but everybody is supercharged because of the whole AI platform. And as you heard, at every single step of the way, governance is applied to the AI. So the result of this is a user-friendly Shiny app that's fully governed and straightforward to use. So there are all of these different views that you can see here that it takes care of. It even shows reports on the status of the cohort progress. And so the best part is that Magnetron is domain agnostic. It's usable for any purpose, and it retains all of its AI governance capabilities. So that means it's usable for a single community of practice, like the data science and AI community of practice that I created, or a single sector of the company, or for multiple sectors of the company, meaning that the multiverse of scalable use case possibilities is infinite. And so overall, Magnetron accelerates trainer-trainee matching at scale, and it originated at the idea of different colleagues inside of Regeneron, and we all work together to make it a reality and to make sure that it's a safe and high ROI solution. I think that's about it. I don't know if there are any questions at all, but yeah. Yes.
Thank you, Dr. James. That was a lot of information, and I was thinking about. Well, first of all, let me say I like the way you might not have noticed it, but in the beginning, you linked the keynote with what you did with data science, because at the foundation, I don't know if you remember, the foundation chart was truth, right? So
Yep. Yep. Absolutely. Truth is the core. Yep.
My question is that a lot went into this, right? I see API governance, I see AI governance, I see like metadata management, right? Because you democratize and use the metadata, right? So when you were compiling all of this information, was it a matter of you making these decisions, or were there a council, or, you know, could be all these different aspects of governance had to be interplayed to make sure this product was of good governance, right?
Yeah, absolutely. So there was primarily a team of 3 people. So I wrote all the code for this, and I was working on the strategy with Jordan and Jennifer on line 3 here. So when we were thinking about the governance steps, and so wait, let me make sure I recap the question. So you were saying how were the governance solutions arrived at? Because there's so much that was done, right? That's what you're asking. What kind of team went into making the decision? Yeah. Okay. So what kind of team went into making the decisions for all the different governance aspects? So it was the 3 of us that were thinking about where governance. Well, it was primarily me that was thinking about where governance steps should be, but who can do what is something that is defined at the early stage here. In every single cohort, the designer is the one who is able to say who can do what. So there are a bunch of different roles and steps throughout the process, but I made it so that the designer can decide on the governance. So there is a governance step, a bunch of different kinds of governances that exist, but who is allowed what governance power, that's actually something I built into the platform too, so that the designer can delegate those governance powers. So it's kind of like I made a meta decision that governance should exist, but how it's doled out, that actually I built into the platform so that I actually am not making that decision, the user is making that decision. Yeah. Yes.
I have a question about implications of this to AI literacy within your organization. So I'm assuming that you have got other data scientists who are working in and that
Yeah.
purpose of this is for you to teach them how to do a better job at data science project.
Yeah.
Using the principles that you have created. Have you started to apply that at Regeneron?
Yeah. So this is, you're not a plant, but it almost seems like you're a plant here. So you asked how have what kinds of steps have been made to teach the other data scientists in Regeneron about these types of AI governance and data science approaches, right? So the RADS group, Regeneron Analysts and Data Scientists group that I made back in 2016, and it actually developed organically. People started asking me for access to the AI development platform, Data Science Posit, things like that. They started asking me for access, so I started giving them access, but I was bringing people together. So we meet every other Friday, and I focus on a different data scientist. It's basically like a talk show. I'm like a data science Oprah at Regeneron. So I just recorded our 49th video where I focus on a different data scientist, and I basically I coach them at the beginning. So we prep 1 to 3 hours before each meeting, and then I get them to flip, because everyone likes talking about the nuance and the scenic route of what they've done. But I always get them to flip it to say, what's the decision that you're trying to make? Because every tool is completely useless if at the end of the day, once you use it, you're no better off than before you used it. So I always get them to flip it to that. And then I'm basically like preaching the gospel of data-driven decision-making and scalable AI platform development. So we've got those videos. I'm also planning to make a large language model powered like a chat bot almost that can leverage the transcripts that I've extracted from the video recordings. So that's one thing I'm doing. But the other thing is here, so I put community of practice. So I've also used Magnetron to do mentor matching for data scientists at the company, so that data scientists who are seeking certain skills, because not all data scientists are seeking the same skills, they can put in what their needs are, and then the providers, the mentors, also can provide what they can offer. And so I was able to use Magnetron to accelerate the data science development. So we have a bunch of different efforts that I've been doing. I hope that answers the question.
A related question is this a bottoms-up effort? Just the community grew from like the way it's organically? Or now do you have any attention from the management to say, oh my God, this guy is really doing something amazing. Let's figure out how to make it a little bit more official?
Good question. It began organically, but I'm regularly in conversations with vice presidents at Regeneron who are really focusing on optimizing our data strategy, our data science strategy, AI, all of these different types of things, and leveraging the resources that we already have. So it's starting to hit an inflection point. It's already federated across the whole company. All the sectors of the company that we have are represented in the data science community of practice, but there are more efforts that are beginning, and people are kind of reaching out to me to accelerate this. All right, I don't know if there are any other questions, but thanks. Oh, yes.
Are you leveraging or thinking about leveraging upper level ontologies and semantics in the future to pull together solutions like this?
So when you say upper level, do you mean like the ones that are hosted on OBO Foundry, for example? They have like at least 100 ontologies. Is that what you mean? Pre-existing ontologies, or?
Existing or created, just like the idea that semantic metadata governance are all the whole things.
Yeah.
All of the inputs and outputs are consistent with our whole machine learning.
I'm not exactly sure how that would play into here. I mean, I would be open to it, but what I have done for, maybe you're getting at reusability. One of the features that I built into Magnetron is there's actually I didn't go into any of the details of how the algorithm works, but basically people are represented as these vectors, these embedding like types of sets of numbers. And those numbers are for different attributes that are of importance. So like if you're going to like a fishing mentorship cohort, some might be like putting the worm on the hook. Others might be like casting your line, right? Those things are what are defined at the very beginning by the designer. And so every time a designer either makes or selects a goal, that goes into a globally shareable library. So anyone who makes a new cohort in the future, they don't have to do it alone. They don't have to invent all of the topics that define the context in which matching occurs. They can just rely on the previously crowdsourced topics. Now, it could be possible to build an ontology on top of that because these are essentially terminal nodes in an ontology. So that could work. So that's something that could be considered.
Or higher level, if I can pick from it and get the same attributes and consistent definitions across multiple models, great. But the governance around those definitions and metadata attributes of those objects that want to be reduced.
Right, yes. So presently, governance is only at the level of the person that created the goal, but other people can use those. But yes, that could be something that's considered. And actually, I should mention that the reason why that's super important is because people, when they pick cohorts, can make useless topics. And then now you have, it's not garbage in, garbage out, but the context itself is suboptimal. So, or you could like match people on the basis of whether or not they like red and blue. That's not important. It's more important that they be matched on the basis of the things that are differentiating between people. So you can see who's a good match and who's a bad match. All right, well, thank you, everyone.